In this video, we are going to review some factoring and fraction rules, and then we're going to be doing them actually with just random expressions and shapes. So just to review, these are the fraction rules on how you work with fractions. So when you're adding fractions, remember that you need a common denominator, and then you're just going to add the tops when the bottoms are the same. Subtracting is the same, except for you subtract the tops and keep the bottoms the same. Multiplying fractions, you just multiply straight across the top, so tops times tops, and then straight across the bottoms times bottoms. You do not need any common denominators. Same with dividing, no common denominators needed. You'll just change from dividing to multiplying by the reciprocal, so you'll end up flipping the second fraction. So if we just took a look at just a random example here, so if we had it like this, a over b divided by c over d, you would change that, so you'd keep the first fraction the same, and then you would change this to multiplication. So instead of dividing, you'll multiply, and then you'll flip this. So you'll multiply by the reciprocal, and then you would follow the multiplying rules. So let's take a look at a couple examples in fractions with just random things written in, okay? So barely any numbers, not even variables, just words, okay? So we've got can over 3 times pen, plus 2 divided by 5 times can. So remember that we need common denominators. So that means you're going to want to look at the factors in the denominators. So we've got 3, we've got pen, we've got 5, and we've got can. Those are kind of all our distinct factors. So we need to have all of those represented in the denominator. So on this side, we still need to multiply by 5 and by can in order to have this denominator represented over here. So when you're multiplying in a fraction, you can't just multiply the denominator, otherwise you change the entire fraction. So if you're thinking about something like 1/2, if you just multiply the bottom by 5, now you're at 1/10, which is much different. If you think half of a dollar, that would be 50 cents, versus a tenth of a dollar is 10 cents. So you can't just multiply the bottom. So you need to make sure that you multiply the top as well, so that you're multiplying by 1, which means you're only changing the look of the fraction, but you're not changing the actual value of it. So again, if we think of 1/2 times 5 over 5, that would be 5/10, which again is still 0.5, okay, or half. So then on this side, we're going to need to get the 3 and the pen in here, okay? So we're going to have to multiply by 3 and by pen. Again, we'd have to do that on the top as well. So now you're just going to actually multiply these together. So when we're multiplying, so we have 5, and there's really like a 1 here. You can think of there being 1 can up here, right? So we multiply the numbers, 5 times 1. And then you have 2 cans multiplied by each other. So remember, when you're multiplying, that changes the exponent. So we actually have can squared, okay, divided by then all of these on the bottom. Now we can multiply the numbers together. We know what 5 times 3 is. That's 15. And then we have can and we have pen, okay? Well, those aren't the same word, so we can't put those together. They're not the same base. So we just have 15 can times pen, okay? Plus, then on this side, on the top here, we would have 6 pen. And on the bottom, 5 times 3 is 15. And then we have can and we have pen. So now you can see that these denominators are exactly the same. It doesn't matter what can and pen are. It doesn't matter if they're variables. It doesn't matter what they are, but now our bases are exactly the same. So now we're going to be able to add the tops and leave those bottoms exactly the same. So I'm just going to write that one denominator. So now when I go to add these tops, okay, remember that when you're adding, you have to have like terms, okay? So this is significantly different than this. This is talking about can squareds, and this is talking about pens. So we are just going to write them both down with a plus sign in between, because they are not like terms. Now, if we had something like this, 5 can squared plus 10 can squared, now we have 5 can squareds and 10 can squareds, so we could put those together as 15 can squareds. Totally fine, because they're the exact same term. Okay, if it was like this, you could not. This is talking about can squareds. This is only talking about cans. Cannot put those together. All right, then if we're taking a look, so then that would be our final answer. We can't simplify that any further, okay? There's nothing to simplify here, so that would be our final answer to that one. Okay, this one over here. So let's go ahead and decide what we need in this denominator that we have here. Okay, so we see the 3. Over here we see a star and a heart. Okay, so we're going to have to multiply by a star and a heart to get those represented here, top and bottom. Okay, over here, we just need this 3 to get them to be identical. So let's multiply all these tops together. So we've got multiplication here. So we've got a heart, and then we have star squared because we multiplied 2 stars together. Okay, and I just like to write the numbers first. So I'm going to write 3 star heart on the bottom here. Okay, this next one, we'd have 3 circles on top. And then on the bottom, again, I'm going to write the 3 first. Then I've got the star and the heart. Okay, now looking at the denominator, because subtracting fractions, you need a common denominator. Okay, we have that. So now we're just going to put those together. So let's I'm just going to put the one denominator here, 3 star heart. And on top, okay, are these like terms? No, because this one is a heart star squared and this one is a circle. So again, we can't actually put them together or simplify any further than just putting a subtraction sign between them. So then that would be our final answer. Then let's take a look at multiplying. So now again, multiplying fractions, you just multiply the tops times the tops. So we're just going to take can times 2. So that's just going to be 2 can. Then we're going to multiply the bottoms. So 3 times 5, which is 15. Okay, and then pen times can, which are not the same terms. Okay, so we're just going to write them down next to each other. That's it. Okay, now if the 2 and the 15 could simplify, sure, you could do that. Okay, and now we can actually see that both the top and the bottom have a can factor in common. Okay, so you can kind of think of it like this. So I'm going to pull that can off to the side, and then I also have this can. Okay, because this is still multiplying, right? So this is just 2 times can, 15 pen times can. Well, what's anything divided by itself? 1. So this is gone. So you're down to 2 over 15 pen. That would be it. Dividing. Okay, so dividing, we're going to leave the first expression the same. We're going to change to multiplication, and we're going to flip this one to its reciprocal, which just means literally flip it over. So the bottom becomes the top becomes the bottom. Then we'll multiply straight across. So you'll have a heart, and then you have star times star, which is star squared. And then on the bottom, you have 3 times circle. Nothing in common here. There's no common factors top to bottom, so this would be your final answer. Then let's take a look at some factoring here. Okay, so factoring with just some words happens to be my niece and nephew's names. So let's take a look at this. So you want to look at what they have in common. So let me write down one that this is sort of like. So this is kind of like I'm doing 10x squared y minus 4x. Okay, because we see Anna here and here. I just replaced her with an x and then Ames with a y. So you're looking for what's in common to factor out those common factors. So first, let's take a look at what's in common between 10 and 4. Well, a common factor would be a 2. Then you hopefully also see, okay, that Anna is in common between here. So this is actually 2 of them, right? This is actually Anna times Anna. So we've got 2 here, 1 here, so we're going to pull 1 out. And then Ames is only in the first one. He's not in the second one. So what would be left? After you take a 2 out of the 10, so 10 divided by 2 would be 5. You took one of the Annas out, so you'd have 1 Anna left. Okay, Ames is still there because we didn't touch him. Okay, and then here we took a 2 out. So 4 divided by 2 is 2, and then that Anna came out. Okay, so if we were to multiply this back in, right? Okay, you'd end up with 10, 2 Annas, and then the Ames, and if you multiplied this all the way over here, you'd get 4 Anna. Okay, if you thought about distributing it back in. So then let's take a look at this bottom one. So, oh, I didn't change this. I have this one. I have this one wrong. This one should say Allie here. I thought we have something that we can take out. Or actually, this should say Jordan. Let me change this to Jordan. Okay. So now let's take a look at this one. So let's take a look at what these have in common, because it's only a binomial, so it's not going to be factoring a trinomial. There's only two terms. Okay, we see Jordan in common here. So we're going to take Jordan out front. Okay, we're going to divide that out. And then what do we have left? Well, when we divided Jordan out of here, we have Allie squared. Okay, and when we divided Jordan out of here, we have minus 9. Okay, so this would be much like if you had something like this, x squared y minus 9y. And you divided a y out, then you'd be left with x squared minus 9. Now there's something special about this. This is a difference of squares. So if you remember factoring differences of squares, okay, we'd square root each term. So square root of x squared is x, square root of 9 is 3, and then you'd have a plus and a minus version of that. So this is going to be the same thing over here. Okay, so we've got this Jordan times, and now we're going to factor this. Well, the square root of Allie squared is just Allie. Square root of 9 is 3. And so we'd have two of these, one with a minus and one with a plus. And then that would be our final factored version.